Hello everyone, welcome to Solving Codeforces Problem Life। तो आज हम अगेन कुछ क्वेश्चन सॉल्व करने वाले हैं रेटिंग 800 टू 1400। तो लेट्स सी हाउ इट गोस। हमारा कॉन्टेस्ट स्टार्ट होने वाला है कुछ राउंड वी हैव अराउंड 20 seconds. If anyone wants to attempt it, link is in the description. You can just open it and तो हमारा फर्स्ट प्रॉब्लम है न्यू ईयर केक। Monocarp is going to bake a New Year cake. The cake must consist of at least one layer. The size of the top layer of the cake must be 1. The size of the layer below it must be 2. And the layer below it must be 4, and so on. Each layer except the top one is twice the size of the layer above it. Additionally, each layer must be covered with either white or dark chocolate. To cover a layer of size K, Monocoque will need K kilograms of chocolate. Each layer must be covered with exactly one type of chocolate, and these types must be alternate. If some layer is covered with dark chocolate, both the layers directly below it and the layer directly above it must be covered with white chocolate, and vice versa. Monocarp has a 8 kilogram of white chocolate and B kilogram of dark chocolate. Help him. He wants to calculate the maximum number of layers that the cake can consist of, ensuring he has chocolate of both types. So basically, in this problem, it has 8 kilograms of dark chocolate and B kilograms of white chocolate. And suppose, like, if our first layer has, like, let's say dark chocolate, then second layer should have like white, then again third should have dark, then fourth should be white, and so on. And the value of these should be like first one is 1, then second should be 2, then third should be 4, then fourth should be 8, and so on. Also, one more thing. Yeah, these two are the basic conditions. So we have to find the how much layer like we can make it. So basically, we can use two strategies. Like first one should be start with dark as the first layer, then white, then dark, then white, then dark, then white, and so on. Keep doing it until you don't have enough for a particular layer. Second strategy will be like start with white, then go to dark, then have white, then dark, then have white, then dark, and keep continuing these things. And whatever the maximum answer that you got in these two layers, we have to like print those answer. So let's try to code this thing. First, we have to take int a and b as input. So we will take it a and b as input. We can have one more variable like current a and current b and answer one and into value one and count equals to zero. So if count modulus 2 equals to 0, we will simply reduce the value of current A. So if current A is greater than value 1, then reduce it by value 1 and simply yes. Else we have to just from here. Similarly, current B is greater than equals to value 1. Else again we will break it. At each level, like value 1 will increase by twice, count will increase by 1, and number of layers will also increase by 1. Now we will do the same thing for the opposite. Like current is 1, here this is answer 2. And this thing we have to follow it like this with 1. Finally, our result will be max of answer 1 and answer 2. And our output is 1 triple two 322. So we are getting the correct output. Now you can simply try submitting this code. As you can see that our code got accepted. Let's move on to our second problem, that is gorilla and the exam. Due to a shortage of teacher in the senior class of the T generation, it was decided to have a huge male gorilla conduct exam for the students. However, it is not that simple. To prove his competence, he needs to solve the following problem. For an array we define FB as the smallest number of the following operations required to make the array be empty. Take two integers L and R such that L is less than equals to R and let X be the minimum of BL to BR. Then remove all such BIs so that BI equals to X from the array. The deleted elements are removed. The indices are renumerated. You are given an array A of length n and an integer k. You can choose an index I and the integer p and replace ei with p. And basically, we are given a t, n, and k, and okay, so we are given n, k, and n elements. Now let's see. For an array, we define fd is the smallest number of the following operations required to make the array be empty. Like we can take two integers L and R and let X be the minimum of this. Okay. Then remove all BIs from that and related elements are removed. The indices are renumerated. Okay. We are given an array A of length m and an integer k no more than k times. You can choose the index I and an integer p and replace ki with p. Help Gorilla determine fp that can be achieved after such operations. Okay, we can basically change k elements from these numbers, from these arrays, and we have to find like what will be the smallest FA in this. Let's say if this is the case 2, 2, 3, we can change the count of 1, 3, and then like it will become 1. Similarly, here we can change 3 elements, then our answer will become basically 2. If you see in this one, like we can't change anything, so it will be 1, 2, 3, 4, 7. So answer will be 5. Like one strategy that I am thinking of is we can start changing the the count of numbers which has like least count and consecutively go upwards. And then in the end, like whatever distinct elements are left, like that will be our final answer. We have taken everything as input. Now we can do one thing. First, we will store the count of each number here. Okay. Put another code on our test cases. Let's see. We are getting 112521. 112521. Okay. So what we did is like first we store the count of each element. We store that in the list of pair. We sort them by the count, and now we start replacing each element from the end. And finally, we calculate the answer, which is like at least there will be one element of max of answer comma 1. Now, if we try submitting this code, As you can see that our second problem got accepted. Now we will move on to our third problem, that is subsequence update. So in this problem, you are given six, an integer sequence A1 to AN and a segment L to R. You must perform the following operation on the sequence exactly once. Choose any subsequence of the array A and reverse it. Note that the subsequence does not have to be contiguous. Formally, choose a number of indices I1 to Ik such that this, then change ith element to the original value of this. Find the minimum value of AL to AR. So basically, we are given N, L, and R and N elements, and you must perform the following. Choose any subsequence or a sequence A and reverse it. Okay. Note that the subsequence does not have to be contiguous. Okay. Basically, in this problem, what we are given is the N, L, and R, and basically an element. Now we can reverse any subsequence. Basically, let's say if we choose A1, A5, A7, we can reverse it. So after performing these kind of operation multiple times, we have to find what is the minimum value of AL to AR. Basically, AL, AL plus 1, AR. Sorry, this operation we have to perform at most once only. Now we have to find what we have to minimize that value. Now suppose for this one, we can simply reverse it. Array will become 1, 2, and our answer will become 1. In this one again, 1 can come this side instead of 3. So yeah, we can change it. Okay. So first we will do is This is our left side of the array, like basically 1 to L minus 1. Then this is the our like center array. This is our right array. Can even keep the count of this thing. And we are getting an error. So output is 136311 8. 136311 8. So if we try submitting this code, you all can see that our third problem got accepted. Now we will move on to our next problem, that is AB construction. There is a string T of length n such that Ti equals to A for all odd I and Ti equals to B for all even I. One day, Bob generated a string S with the following algorithm. Initialize S to the empty string, remove either the first letter or the last letter from the T, and append it to S. If T is empty, terminate and return the string S. Otherwise, go back to the second step. Then Bob wrote down the generated string S on a note and forget about it for a few years. The note was worn out when Bob found it, and someone might have secretly changed some letters. Of course, Bob wants to know if someone did alter the string. We are given a string x of length n, which consists of a, b, and question mark. Please determine if there exists a string a which satisfies the following condition. Now let's consider the case of an odd one, like when n is odd. So if n is odd, then our t can be something like this: a, b, a, b, b, and a. Now Now let's see. Now suppose we have to make S out of this string. Now, now whether you choose from the left or right, you have to choose A as your first element. Now in the second case, suppose you have chosen A, this one. Now second time you can choose either of one, either A or B. Now suppose if you have chosen A, if you have chosen previous one as A, now you have to choose B because both becomes B. But if you have chosen B, then you can choose A only. Now suppose last one was B. Uh, So this is A, this is done, this is done. Now you have already chosen B. Now next one can again be either A or B, and this pattern will keep following it. Now consider the case when it is odd, it is even, sorry. So it will be like this. A, B, A, B, A, B. Now here, first one can be either A or B. Now suppose you have chosen already A, then it will become B. If you have chosen B, then next one has to be A. Now suppose first one you have chosen A, the next one will be B, and this one will be again A or B, and so on. Like this kind of pattern will keep following it. Now just we have to make sure that the string that we are taking input is following this pattern or not. So let's try to like code this one. First, we are taking any string as an input. If n modulus 2 means n is even, in this one, like all the even integers are dependent on the previous one. So let's say if I modulus 2 equals to 1, this is our current character and this is our previous character. Now, if either current character is like question mark, If previous character becomes question mark, then we can simply continue because we can put any character of our choice in this problem. If this is not true, then current has to be not equals to previous. If current and previous, like let's say, becomes equal, then our result will be false and we can break out of it. Here we can keep it boolean result equals to true. Same thing we will be following here, but in this first character has to be A and then subsequent even character like we are following same way. So this thing is applied for this and if I equals to 0, we have to continue basically. If current equals to B, then our result becomes false and we can break out of it. If result is true, and else false. If we try to run our current code, we are getting yes, 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 and no. But for the third one, we should get no. But why we are getting yes? Let's check our code. Sorry, this should be first preview. Sorry, we have to follow this code for n modulus 1. Let's try for like second test case why we are getting yes. Our input is BAA. And it should follow something like this. A, B. The first character has to be A only. Okay, so this should be like this. Yeah. I think this condition itself should be enough to make this as false. Let's see what is the reason here. Hmm, I now we are getting correct output. We did not take another input. I think that was one of the reasons. But now we are getting yes, no, which is like our output. So yeah, let's try submitting this code. As you all can see that like yeah, our code got accepted. So now let's move on to our next problem that is max tree. We are given a tree consisting of n vertices numbered from 1 to n. Each of the n minus 1 edges is associated with two non-negative integers x and y. Consider a permutation P of integers 1 through n where P represents the value assigned to vertex I. For an edge u comma v such that u is less than v with associated value x and y, its contribution is defined as follows. X if pu is greater than pv and y otherwise. The value of the permutation is the sum of contribution from all edges. Your task is to find the permutation P that maximizes the total score. Now, for any edge u comma v, suppose let's take this as an example. Uh, we are given a tree with three nodes. And for the first stage, as the value of x and y are 2 comma 1, and for second it is 3 comma 2. This is between 2 comma 1 and this is 3 comma 2. And finally, the value of the permutation is basically the sum of contribution from the all the edges. Suppose this is the final answer 3 to 1. Let's say 3 to 1. So it will be contribution from this edge and this edge. Now we are taking the value of x if pu is greater than pv. Basically, in this case, 3 is greater than 2. So we will take 3 as the contribution. And again, in this case, 2 is greater than 1. Then we will take 2 as the contribution. So for this one, our answer will become 5. So this is the permutation that maximizes our total value. We have to see like how we can assign the values to all the nodes. For this one, it was quite simple, like 3 to 1. But let's see for this problem. In this, there are 5 nodes. So let's try to draw the tree. First, it is between 1 to 1, 5. There is an edge between 1 to 3, 1 to 5. Now 2 to 4 and 3 to 3. So, and 3 to 3. Now, if we see the value of each edge, now it is between 1 to 3. This one is between 1 to 3. This one is between 2 to 1. Next is between 5 to 7 and 1 to 100. This 7 and this is between 1 to 100. Now, one idea I'm thinking of is, let's say if we assign, let's say, any value to this x. Now, if we are assigning, let's say, something greater than x to this value, then we are getting actually this is the answer we are adding. Similarly here, but if we are assigning smaller than this, then we will add this 3 to our answer. And they are like various test cases because if we have to also keep in account for like suppose here we have taken it, but in this test case we have to also keep because it is contributing quite large, like 100 numbers to the test case. So this becomes quite more important. Suppose if we are adding, let's say, 1 and 2 to the s, and suppose 1 is the smallest number, then we will be adding y. If 2 is the smallest number, then we are adding x. Similarly, we can do for this thing in this. If 1 is the smallest number, we are adding x. That is, in this case, y is our 3. This is x is 1. In this case, y is 1. If we are taking 5 as smaller, then we are adding 2. Similarly, if we go with 2 comma 4, we are adding 7. Then 4 comma 2, we are adding 5. And last one, this one, uh, with 2 comma 3, we are adding 100. And 3 comma 2, we are adding 1. Now, one approach I'm thinking of is like sorting this by descending order. So let's take this as our first edge. So if we take this our first edge, then 2 will be having the value. Let's say assign 1 to this, and 3 can be anything. We are not keeping in mind. Then second is this. Again, we don't care like because 2 is already assigned. Similarly, if I go to this one, 4 comma 2, here 2 is assigned, so we don't care. The third number is 1 comma 2. Here again 2 is assigned, so we can't do anything. Now next one is 5 comma 1. Yeah. So here we can assign something to the 5, and it should be the second smallest number. So we can assign 5 as 2, and rest of the number we can normally assign to them. According to this problem, I think 2 should get the first number and 5 should get 2. Here they have reversed it, but I think this should work out. I'm thinking of what can be the downside of this. Because taking, let's say, 2 as the smallest number and actually adding 107 and 1. I think this might be a better approach. Like at each for each node, let's take like what if you add like this number as the smallest, then how much it is contributing. Then similarly for other nodes and consecutively, and then provide the value normally. I think this might be the most logical approach that I'm trying to think of. So yeah, let's try to code it, like and see if this works out or not. So basically, we are given n. Now we have to take as input. So if int contribution, like for each for each node we are seeing like how much it is contributing, and then simply take all the vertices as input. Now for each vertices we are taking u, v, x, and y as input. U, v, x, and y as input. Now we have to see if u is the smallest one. So contribution at u. If u is the smallest, then it will add y and we will reduce x. Similarly, if v is the smallest, then we will add x and reduce y. Finally, we can make a list of pair to find out what are the smallest ones. So we will add all the pairs, like how much they're contributing and what is their node value. I, comma, contribution at I. And finally, we will sort based on their contribution value. Finally, our result, we can make a new answer array. It will be this for the finally we will print our answer. Okay, let's try reading our code. Okay, again, we have to submit this only to get the check if it is correct or not because there are like multiple answers to this. We are getting the wrong answer on test case 1. Let's see why. For test case 2. Okay, let's see what was the contribution for each of the nodes. This, if you can see, second node has the maximum contribution, then first, then fifth. But I think as soon as we have added 2, whatever nodes it is contributing suddenly becomes null and void. Now, logically, in this case, now we have to only see the edges which are like not contributed by the node 2. So in this problem, how many nodes we can have? 2 into 10 to the power 5. I think our approach was correct to some extent, but like we have encountered one issue is this. Like as soon as like our current node is full, the all the edges which are connected to this like now have like no contribution in this. So we have to update the value of each node after this instance. Okay. So yeah, we can for this thing I think we will have to take a priority queue actually because that might help in addition also. And to iterate through all the childrens of this one, we will have to make an array list actually. If do is the smallest, then we are basically adding y and x. And this is one Boolean array. We are getting some exception here for prior to key of fear. Same. Let's see if we don't add anything. Okay, we are getting which one? Sorry, we are getting this issue. Think maybe the issue can be like we are not defined like how like this should work out. Can be like another but yeah. Then while defining priority queue, we always have to define like how we are sorting it and all. So I think now this should work out. Getting the wrong answer. Let's see what is the issue again for test case two. Let's see what we have here. First, we are removing not two. So I think well, yes, not two should be one. Yeah, there of course is just like how one we have defined three actually. Okay, we encountered another issue here. Like according to this, if we add one to this, into this we have an edge like this. This is four. Okay, so this thing that one should have a higher value than two. Okay, okay, yeah, I think we have encountered the issue and probably this might also not work out. But now I think the approach that I am currently thinking of is probably going with the topological sort, means basically find the any pathway, and for that we can do is like this thing. Suppose there is an edge between u and v. So if let's say x is greater than y, then you want basically you want the edge between u to v, edge between u to u. So here we can do this as u dot add v, and here this as v dot add v. Now we will integrate the result written in Boolean array also. Here in the last finally, like we will print our answer. So If you try running this page, let's see what you're getting. Sorry, not count. Where's the page? Page to be with the page should be one. We're getting one, two, three. Okay. We're getting one, two, three, four, and five as our output. Let's see the reason for this one. We will just move to let's try to test it. Very good. And this code is working or not. You can see that our code got accepted. So I will summarize this in like short, like what I did. So basically, you are given, bring it here. You are given a basically a tree, and you have to identify like how you put it such that the sum of the value is like maximized. So as an example, first suppose any tree you can take it, like the one we are taking it, we can take that one only, one and two. So one, there is an edge between one and two, one and five, two and four, one and five, then basically between two and four, and then between two and three. Okay. Now, now suppose here value is between one to three. Now in your score, like you have to maximize the score. Now in your score, if value at like AR at 1 is greater than AR at 2, then you will add 1 to the score if this is true. Else you will add 2 to the score. Basically, if there is an edge between 1 and 2, and if value at 1 is greater, then we are adding this, else we are adding this. And as you can, so sorry, like speak the opposite. Like if this was the true, then you would be adding 2, else you're adding 1. Basically, if there's an edge between 1 and 2, and if this value is greater, then we are adding 3, else we are adding 1. So, 1 second, can remove this and add 3 here. So this is our like main logic here. Now what we are doing in our code is like first we are try to create a tree. Suppose this is our mm, input. Now if x is greater than y, let's say in this case although it is opposite, like suppose if x was greater than y, then we will like create an else with tree like 2 to 1. Else we will do from 1 to 2. And and we will like suppose in this pattern we will create some kind of tree, and finally we will find the like Like using, we find a path using a topological sort and then iterate through through topological sort and keep assigning value from n to 1. So this was like the whole idea for this problem. And we have tried like multiple things here, like as you have seen there, but there was like it was not working in like of n because we have to iterate through all the nodes, so it was taking somewhere around of n square. Yeah. So this was like a good problem of like graph in which we shifted using topological sort. Now we will see our like the last problem for today, that is permutation counting. In this problem, you have some cards, an integer 1 and n written on each card, especially for each I from 1 to n. You have EI cards which have number I written on them. There is also a shop which contains unlimited cards of each type. You have K coins, so you can buy K new cards in total, and the cards you buy can contain any integer from 1 to n. We are given an integer n, and for each I 1 to n, you have EI cards which have number I written on it. Okay. There is also a shop which contains an unlimited cards of each type. You have K coins, you can buy K new cards, and the cards you can buy can contain any integer between 1 and n. After buying the new cards, you rearrange all the cards in a line. The score of the arrangement is the number of contiguous subarray of length n, which are permutation. What is the maximum score you can get? This is given by zero score of type 1, 4 cards of type 2. And so we have like AI cards of type I in our problem, and we have to see like how many permutations we can make in this problem. Okay, like if we see our third problem, we will take third as an example. We have n is 3 and k is 4, and card of each types are 6, 1, and 8. Okay, 6, 1, and 8. I think best approach is to put all in this. So this will become 6, 5, and 8. Now you can make permutation of type like 1, 2, and 3. Total five of this part, right? Now similarly, we keep putting it like this. Um, Total five we will be able to put it. So five are these, then two, three, one. These are of total four. So five plus four. Then there are of type like three, one, two. These are also of four size. Now still we are left with one, one, and two, three. We can utilize this three by keep putting it here. So this will also become a one permutation. We can even utilize this one by putting it here somewhere around here. And maybe instead of using one, two, three, we can use something like two, one, three. In this way, this will also become one kind of permutation. So total we will be getting 15. So here like first idea of ours can be like to make each card of type equal and then utilize the remaining them to like build something. As an example, in the fifth one, like we have 66746. Six, six, seven, four, six. And we have three extra cards. So best strategy will be to make this also a six. It will become and give seven to someone else. Anything. So we will have card of this order. Now again we can utilize maybe one card we have extra, so we can provide to someone else. Maybe this one. So you have two extra card of three and five. So three and five we can keep in the starting. And now try utilizing each card. So like this. One, two, four. Like this of six patterns we can make it. So total will be six plus five plus five plus five plus five. And finally using these two also, we can make two extra. So our answer will become like 20, 25 plus 3, 28. So I think for the fourth one, for the fourth one, it should be 28. Like, sorry, fifth one, it should be 28. Yes. So this is the like approach that we will try to implement it. Basically, like first try to make uh, all of them as equal, and then we can redistribute them, redistribute the remaining them to the starting. So let's see how we do this one. First, We take n and k as input. We have to take an array. You can take an array as input. Um, and what is the value of minimum value that we can distribute? This can be the value. Check whether we are able to distribute mid to all of them. So if priority is let's say less than mid, then we will remove this much from the mid. So mid minus prioritize. Now, at any instant, if current becomes less than zero, then we will. This is simply a binary search. Like we are trying using binary search to find like the correct mid current value that each of the cards will get it. And let's see each card is each card is getting this. So now we have already found out like each card is getting this value. Now just redistribute them. If ARI is less than each, ARI is less than each. Our answer will be basically like for this example, let's say it was our mid was 6, so everyone was getting 5 except one. So look here again, everyone will be getting each minus 1 into long n, and one of them will get one extra. And in the starting, we are adding case. So this is the starting point, and finally, we can print our result. Let's try to run on the given test cases. Mm, it belong. We are getting 11, 15, 15, 22, 28, 11, 15, 16, 17, 32, 28, 36. 32, 28, 56. Our given test case got passed. Like, let's try to submit this one. As you all can see that, yeah, this one got accepted. Yeah, I think this was pretty easier, but yeah, compared to last question. In this, what we did is basically find the value each, which like each of the card will get. Now, as soon as you have find each of them, now we will see that what are the extra number of cards which are remaining. That also we find out, which we will store in the cave. And finally, we assigned like each minus one as we have checked here. Like suppose each card is suppose there is a count of seven for each card. Let's say there are 10 is our five. So we were creating like this 1 2 5 1 2 5 1 2 5 like this. Total seven permutation we are able to create it. Now if you see 1 to 5, this permutation is of total 7. Now second of type, let's say 2, 3, 4, 5, 1. This will be of 6. Its count will be 6. And similarly like this. So basically here we are just like if count, each count is 7. So each minus 1 into n and there is one extra one. So that we are adding. And there was some numbers that we were adding in the starting that we can simply add to our answer. So this is the basically thing we did here. Each minus 1 into n, then result plus 1, and finally result plus 2. And print it. Uh, so overall, like we were able to solve all of the six problems. I think that although we get slightly, we were not able to solve in that time, but yeah. Uh, so that's all for this one. Like I will back tomorrow. Like mostly we will be solving even the today we tried from rating 800 to 1400. So tomorrow we will be solving till 1500 rating problems. Yeah, thank you.